Why do we say that it took humanity 300 years to finally catch the tail of light, only to discover at the very last moment that we had been deceived for a full 3 centuries? Before the 17th century, everyone believed the speed of light was infinite. In 1607, Galileo refused to believe it. He stood on top of a hill holding an oil lamp, and had his assistant hold another lamp on a distant hill several kilometers away. He tried to calculate how long light took to travel that distance by uncovering the lamp at the same moment. And what happened? Nothing was measured at all. Galileo realized in despair that human reaction time was laughably slow compared to light. Even more frightening was that over the next 60 years, countless scientists tried one after another, and every attempt ended in failure, until 1670, a Danish astronomer, staring at Jupiter's moons, noticed something that made everyone's scalp go numb. This man, Ole Rømer, was working at the Paris Observatory, observing Io, Jupiter's innermost moon. Using the most advanced pendulum clocks of his time, he precisely recorded the time it took Io to complete one orbit around Jupiter. But something strange happened. When Earth was moving away from Jupiter, Io's orbital period became a full 13 seconds slower than when Earth was closer to Jupiter. Do you know what that meant? Either the moon's orbit was perfectly synchronized with Earth's motion, or the speed of light was not infinite. Rømer chose the second answer. He began calculating obsessively by measuring the time difference between Io entering Jupiter's shadow and leaving it, and combining that with the diameter of Earth's orbit. Rømer reached a conclusion that shocked the world. The speed of light is about 230,000 kilometers per second, although this value was about 25% lower than the true value. For the first time in human history, infinite light was assigned a concrete number, and yet irony struck hard. Rømer's discovery was met with fierce resistance. Most ironically, his strongest opponent was Cassini, the very man who provided him with Earth's orbital data. As director of the Paris Observatory, Cassini had also tried to measure the speed of light using the same idea, but because he didn't observe similar effects in Jupiter's other 3 moons, he completely rejected the idea that light had a finite speed. Cassini spent his entire life insisting that light speed was infinite, and even on his deathbed, refused to admit that Rømer was right. This debate dragged on for nearly 50 years, until 1728, British astronomer James Bradley delivered the most powerful proof in Rømer's favor. Using a completely different method, Bradley's original goal was not to measure the speed of light at all. He wanted to prove that Earth really does orbit the Sun by observing changes in the apparent positions of stars. But fate played a joke on him. He did not find the expected parallax. Instead, he discovered an even stranger phenomenon. The positions of stars shifted within just 3 days, and in a completely unexpected direction. Bradley was utterly baffled, until one day, while sitting on a boat on the River Thames, he noticed something about the weather vane on top of the boat. When the boat changed direction, the vane's pointing direction changed as well, even though the wind itself did not. In that instant, everything clicked. The apparent shift in starlight was caused by Earth's motion, combined with a finite speed of light. Through geometric calculation, Bradley determined the speed of light to be about 295,000 kilometers per second, with an error of only 2%. Even more astonishing, he calculated that sunlight takes 8 minutes and 12 seconds to reach Earth. That number is almost identical to today's precise value. By the 19th century, scientists were no longer satisfied with measuring light speed by observing celestial bodies. In 1849, French physicist Ole Fizeau designed a crazy device, a rapidly rotating wheel with 720 teeth. Light passed through the gaps in the wheel, traveled to a mirror 8 kilometers away, and reflected back. When the wheel reached a critical speed, the outgoing light was blocked by the returning tooth, and no light was visible. Using the wheel's rotation rate and the distance, Fizeau calculated the speed of light to be about 315,000 kilometers per second, although about 5% too high. This was the first time in history that humans successfully measured the speed of light on Earth using an experimental apparatus. But during the same period, another French physicist, Foucault, was independently developing a similar experiment. Instead of a toothed wheel, Foucault used a rotating mirror. Light traveled from the source to the rotating mirror, then to a fixed mirror, and back to the rotating mirror, before reaching the observer. Because the mirror was spinning rapidly, the returning light appeared at a slightly different position. In 1850, Foucault announced his result, 298,000 kilometers per second, closer to the true value than Fizeau's. The competition between these two French scientists improved the precision of light speed measurements by an entire order of magnitude in just 1 year. But the person who truly pushed light speed measurement to its limit was an American physicist named Michelson. This man's obsession with the speed of light bordered on pathological. Starting in 1869, while serving as a naval officer, he began thinking about how to improve Foucault's rotating mirror setup. In 1879, he measured the speed of light as 299,910 kilometers per second, with an error under 50 meters per second. But Michelson was not satisfied. He kept refining his equipment, lengthening the light path. By 1920, he planned an experiment of epic proportions. From Mount Wilson Observatory in Los Angeles, he sent a light beam to Lookout Mountain, 35 kilometers away. After 2 years of extremely careful measurements, he obtained a value of 299,796 kilometers per second, with an error of only 4 kilometers per second. Still, Michelson was not satisfied. The 1925 Santa Barbara earthquake destroyed his baseline. Smog and forest fires around Los Angeles also interfered with his measurements. So in 1929, this obsessive old man and his team built what can only be described as an engineering miracle, a vacuum tube, 1.6 kilometers long and 1 meter in diameter. The entire tube was evacuated to near-perfect vacuum, lined with mirrors, allowing light to reflect back and forth more than 10 times. The effective light path exceeded 16 kilometers. Michelson planned to perform 233 measurements to obtain the most accurate value of light speed ever recorded. But fate struck again. In 1931, after completing only 36 measurements, he passed away. His assistants completed the remaining work and published the final result. In 1935, 299,744 kilometers per second, with an error of 11 meters per second. From the 19th to the 20th century, humanity used every imaginable method to refine the speed of light, from 6-digit precision down to 4 digits. After 1950, scientists adopted even more advanced techniques, and precision jumped once again. By the 1970s, the speed of light had been measured to several decimal places, and then the scientific community made a decision that shocked everyone. In 1983, the General Conference on Weights and Measures announced the speed of light would no longer be measured, but defined as exactly 299,792,458 meters per second. From that moment on, the meter itself was defined as the distance light travels in a vacuum. In 299,792,458 of a second. What does this mean? It means that after 300 years of chasing the speed of light, it was no longer a quantity to be measured, but a standard used to define other physical quantities. All subsequent measurements of light speed were effectively refinements of the definition of the meter. This is what we meant at the beginning. Humanity spent 300 years catching the tail of light, only to realize we had been deceived. Because the moment you turn your prey into a ruler, it escapes forever. From Galileo's oil lamp on a hilltop, to our MERS observations of Jupiter's moons, from Fizeau's toothed wheel to Michelson's vacuum tube, humanity's pursuit of light speed was never just about a number, it was a challenge to the ultimate limit nature imposed upon us, 300,000 kilometers per second. It sounds unimaginably fast, yet, on a cosmic scale, it is painfully slow. Sunlight takes 8 minutes to reach Earth. Light from Proxima Centauri, the nearest star, takes 4.2 years to reach our eyes. If you wanted to visit the center of the Milky Way, that light would need 26,000 years to return to Earth and tell people you had been there. Even more terrifying, because the universe is expanding at an accelerating rate. More than 97% of the observable universe can never be reached. Even if you traveled at the speed of light, the speed of light is not just a speed limit, it is a cosmic prison, designed for all civilizations. It lets us see distant galaxies, but never touch them. It allows us to understand the universe's past, but never change the future distances. This is the truth about the speed of light, an ultimate velocity that took humanity 300 years to truly comprehend, a cosmic constant that appears infinite, yet is brutally limited. From Descartes' vision of infinity to the precise definition of 1983, human understanding of light speed completed an epic leap, and this history tells us, sometimes, the journey of chasing the answer is far more fascinating than the answer itself. Today we know the speed of light is exactly 299,792,458 meters per second. But Galileo holding a lamp on a mountain, our MER spending sleepless nights at the observatory, Michelson waiting beside a vacuum tube, their silhouettes chasing light. That is the brightest light of human civilization.